Yo, this is your boy Leo from UYO Waste. I'm here to show you how to build a 3-bin compost system for next to nothing. Our materials are going to be pellets and stakes. Blah! So, this is where we're going to build the 3-bay compost. 1 bay here, 1 bay here, and 1 bay here. I'll get into it. Now, I'm going to put the stakes in through all the holes and then bang them in and slide them over the top. Pretty noisy, eh? So next up, we need some walls that come out to create the individual bays. So now you can see that we've got 1 bay, 2 bays, and 3 bays. I'm going to leave this wall off because this compost heap is going to get turned into the first bay, which then gets turned into the second bay, and that one starts anew, and then it goes into the 3rd bay for its final conditioning, and then it's ready to go on the garden. Yeah. Now, starting to shape up. Might pay to start putting some material into it and getting that composting going. So, what's the big deal about compost? Well, it's awesome at minimizing waste and it's great for building soil fertility. As you know, in nature there's no such thing as waste, only stuff in the wrong place. So when we're making compost, we're fulfilling that circle of life. When something dies, it becomes food for something else. And then when that dies, it becomes food for something else. And it travels down all of these trophic levels to become soil. And so for me, building soil is like a really, really great purpose in life. I believe we are here to be the guardians and the gardeners of this planet, the kaitiaki. So, building compost is a real science to it, but it doesn't have to be that way. What you do is you're essentially just layering in lots of different sort of biodegradable materials, which is predominantly carbon. 97% of the universe is carbon. When we layer carbon in with nitrogen and other elements of the periodic table, they sort of go through this process that we call composting. There are 2 different types of compost, a mesophilic compost and a thermophilic compost. This speaks to different bacteria which are present. A mesophilic compost is driven by mesophilic bacteria which exist between 20 and 45 degrees. A thermophilic compost is a lot hotter and a lot faster, and thermophilic bacteria exist between 40 and 120 degrees. So what we're trying to create is a compost bin with enough area so that enough heat can build up for thermophilic bacteria to be active and really speed this process up and be a really effective compost. So, the way that we do that is by bringing in lots of surface area and a really good range of different materials. Because I'm transferring this existing compost heap into these bins, I'm taking everything from the outside and the top and putting it into our first bay, and then everything in the middle is going to go into the second bay because it's already been through a process of composting. So it's great to put any kind of like really woody or bushy stuff underneath it, because then that allows the compost to breathe because it incorporates oxygen at a lower level. Same around the outsides. Whoa, check it out. I just found my old Christmas tree. Nearly. So, that's what a Christmas tree looks like 9 months after Christmas. So a long way to go, eh? So we'll get that back in there. So compost is made up of 4 main things: carbon, hydrogen, oxygen, and nitrogen. Like I said before, carbon is everywhere. It's kind of like all the brown stuff, mulch, cardboard, newspaper, these are all carbon. And hydrogen is really common. It's like 21% of the air that we're breathing. But when that's mixed with oxygen, you get water. And all forms of life need water, just like the microbes in the compost. And then the last one is nitrogen. Nitrogen is what plants need to photosynthesize and create energy and feed sugars down to the bacteria in the soil. So this is really what we're creating. We're sort of mimicking a forest floor. And so in order to do that, it's really great to just create layers of nitrogen, like maybe your scraps from your kitchen, nitrogen, and then maybe some cardboard, carbon, and then more nitrogen, and then some water, hydrogen, oxygen, and then more carbon. And generally the rule is more carbon, more carbon, more carbon. The best composts have a carbon to nitrogen ratio of about 25:1. If you want to create a really good compost, you're looking at more like 30:1. Generally, in nature, if there's ever a disturbance, like an earthquake or a tsunami or a volcano, nature sends in weeds to heal the parts of the earth that's been exposed. Humans expose nature all the time. We're constantly damaging it. That's why we call them weeds. But they're not actually weeds, they're just pioneer species that are healing the earth. And so that is essentially what we're trying to do. We're creating soil to heal the earth. So, we've just filled up our first bay a little bit, and now we're going to put on our last wall, and then we're going to start shifting the whole compost over. Me. Nice. Looks good. So, we just fully finished this 3-bay compost system. We'll have a chat about how we're going to use it. This is phase 1. This is where all of the new material goes. And so I'll be building that up over the next kind of like 6 months, and that'll turn into phase 2. This is phase 2. This is kind of like I've just turned a whole bunch of phase 1 material into phase 2, and that's going to sink down again, and that's going to look more like phase 3. This is sort of where it all kind of winds up. And what happens is essentially we're looking at chemistry, physics, biology, and energy, if you want to go there. But what's essentially happening is the structure in here is a lot better. And so can hold our soils together a lot better. This is also a living organism. There's a lot of life, a lot of activity in this. And then there's chemistry, because we've brought in all of these elements from the natural world and we've broken them all down. And so there's a lot of variation of elements here. And so another thing to consider is kind of the scale in terms of when nature is healing itself, it is using a lot of biology. But then if we go into a mature forest ecosystem, soils are generally fungally dominant. So if you've had a really high carbon to nitrogen ratio, then you're probably going to produce a much more fungal dominant compost. So it's better for trees or like restoration. But if you've had a lower carbon to nitrogen ratio, it's going to be a very bacterially rich compost, which is better for your garden, your edible landscapes. So it's easy to get caught up in the fact that compost can actually be a real science, but I wouldn't want to let that hold anyone back. Just have a go at it, have a crack, and if you mess it up, you learn, you do better next time. So I try not to be too dogmatic about how we apply it. If you have a smaller amount of area that maybe keeping worms is a better way to minimize waste and build soil at your place, There's a few other tricky things with worms, but we'll make some more videos and we'll demystify that as well in the future. So I'll just wrap up by reiterating really the purpose, the why we're doing this. And that's because 1/3 of what society is throwing away is biodegradable and can be returned to our soils through these natural processes. When it comes to what we're throwing away from our homes at the curbside, it's more like 1/2 as biodegradable. So that's why I'm here just making a racket about compost. Thanks so much for watching. My name is Leo. I'm a storyteller that uses waste as a platform to communicate big picture ideas. My project leases worm farms into people's backyards and into businesses. It's called YWaste. Check us out at ywaste.co.nz. Cheers.